Okay. I guess we can start now. So how many of you are pre-enrolled to Math 1023? Okay, most of you. Okay, great. So today I'm Tina. I guess I have seen you. You have seen me before doing the Zoom talk. Today we are very happy. We have invited our previous IRE alumnus, Aaron, to give you some tips. Actually, I just bumped into Aaron a few weeks ago, and because he's now studying, not studying anymore. He's now a postdoc in MIT, and I bumped into him because he's just having a holiday here in Hong Kong. And then I asked if he could, give you guys some tips on studying math, honor calculus. He got A+ in this course long time ago, and he's now a postdoc in MIT. I will let him introduce himself a little bit more. So please give big hands to Aaron.
Good morning, everyone. So thanks, Tina, for the invitation and the introduction. So let me introduce myself a little bit more. So my name is Aaron, and I was also an undergraduate at HKUST like 10 years ago. I also took the honor math course, and I graduated at 2018. I went to Columbia University for PhD in math. Right. So today I want to share with you about the honor calculus course, Math 1023, and I want to tell you what to expect in this course, what are the differences between the honor version and the normal versions, and also who should take this course and why should you take this course. Yeah. Okay. Yeah. So this slide shows the core course in the math major requirement. So if you are a math major, then you are required to take the calculus 1013 and 1014, calculus 1 and 2 in the first year. And building upon calculus, you will need to take like linear algebra, abstract algebra in the second year and the third year. Also, you will need to take analysis 1 and 2. So together with the core course, normal core course requirement, we also have the honor version aligned with each course. Okay, so in the first year, the first honor course that you can take are the honor calculus 1 and 2, and Math 1023 is the honors calculus 1. So that this would be the first honor course that you can take. Okay, and yeah, and the honor course is also a foundation for the later honor stream. So if you take the normal version of calculus, then you will find it very hard to transition from normal stream to the honor stream later on. Okay, so now I want to talk about So why should we take the more challenging honor calculus course, and who should take this course? So if you are a math major and if you want to pursue a graduate level degree, let's say a master or a PhD degree in mathematics, then you are strongly recommended to take the honor stream. So the normal math stream is actually not enough for pursuing a higher degree in math. And next, if you want to take more advanced course in math, so if you're a math major, then actually you should choose some of the 3000 level and the 4000 level math course in your senior years, such as complex analysis, manifold, abstract algebra, or even graduate level course. Then this honor calculus course will offer you a solid preparation for you to take these more advanced level math courses. And for example, about 80% of the A-range students in these more advanced pure math level courses had took the honor stream calculus when they were in year 1. Yeah, so in other words, if you really want to achieve a good grade in later on when you study math, then it is highly recommended to take the honor version of calculus. And if you are IRE student, then you are required to take the honor stream. I mean, if you are IRE Math, then you are required to take honor stream. And for those of you who are not IRE now, and if you want to transfer to the IRE track in second year, I mean, if you want to transfer to IRE Math in the second year, then you should also take the honor stream, as these are the requirement for the IRE Math track. Okay, and yeah, and lastly, so this is some like benefits for taking the honor math course. So the math department has a scholarship scheme called the Chern scholarship program, and so the Chern scholarship program comes with a series of scholarship for the math major students. So and the honor stream calculus courses are the requirement for being admitted to the Chern program. Yeah. So let me talk more about on the Chern program. Yeah. So right. So the Chern if you were admitted as a Chern student in the second year, then you will be eligible for a series of scholarship. So firstly, upon admission, you are able to receive up to 10,000 Hong Kong dollars as a Chern student, and there's also financial support up to 5,000 Hong Kong dollars for the Chern student. And last but not least, upon graduation, you're able to receive like a big prize. So depending on your GPA, you can achieve up to like 30,000 Hong Kong dollars upon graduation as a Chern student. So that is called a Chern Achievement Scholarship, and you can find this information in the Math Department webpage. Yeah, yeah, and this chart also shows the eligibility for being able to admit into the Chern class. And the important thing is that you can see that the honor version, taking the honor calculus 2 is a must for being able to admit as a Chern student and receive those HR scholarships. Okay, right. So now I want to talk more about the key differences between the honor versions of calculus and the normal versions, right? So the honor calculus Math 1023. So this is a much more proof-based course, and it is more rigorous version of the calculus. And you are expected to write a lot of proofs in exams or assignment. And these are not straightforward calculations as those exams or assignment you encounter in high school exams. So the logic behind are much more tricky and not straightforward. And the level of the honor calculus align with the level of elementary mathematical analysis. So if you have taken the honor stream of calculus, then you will be you will have a good preparation for mathematical analysis in year 2 or 3 studies. So in particular, the honor version of calculus are quite involved in a rigorous delta epsilon approach when dealing with limits. So that's one key distinction between the honor version and the normal version of calculus. And on the other hand, the normal calculus course, say Math 1013, so it is less proof-oriented and more calculation, and there are more calculation type of questions. So the normal calculus course, so the style of the exam questions or the assignment questions is more similar to those you have seen like M2 exams or high school exams. So the focus is more on the calculation side, and the honor version is more on the proof side. Okay, so although in the normal version, it is possible to have some proof and derivation questions, such as asking you to prove something like the left-hand side equals to the right-hand side. For example, you may have encountered similar questions like like proving some kind of trigonometric identities in high school. So those belong to these kind of derivation questions, proving left-hand side equals to right-hand side. But these questions are not those logically difficult proof in Math 1023. So the proof in Math 1023 is not straightforward. So it might be divided into several steps, and it might require some creativity and insight into the questions. Okay, so let me talk about the difference in course topics. So in the normal calculus course, so if you are DSC students, then you may find that the normal calculus course is a bit similar to what you have learned in M2, although a bit more advanced. So in the first 2 weeks of the class, the normal calculus course will cover basic concepts of functions, and then you will learn how to calculate limits of functions or limit of function or limit of sequence. So the focus is basically on the calculation side. You are not asked to show why the limit exists or how to prove that why the function has this kind of limit, but rather you will be given like calculation questions, right? And for the later topics will be like differentiation and their applications, such as finding tangent line to curve, and like those rate of change type questions. So the normal version is more on the application side and more on the calculation side. So on the other hand, for the Math 1023, the honor calculus course, so when you get into the honor calculus course, you are assumed to know all these topics. So you are assumed to be familiar with the calculation stuff, okay? And you are assumed to know the concepts of like limits or differentiation. I mean, you are assumed to know the intuitive concepts of this. But in the honor calculus course, you relearn all these concepts from scratch and in a much more rigorous way. So for example, you will learn the rigorous approach to limit of sequence and limit of function using the epsilon delta language. And building a point on the epsilon delta language, you will prove some theorems in elementary analysis, such as what does it mean by Cauchy sequence, the monoconvergence theorem, and for example, the Bolzano-Weierstrass theorem. So in this topic, you will learn how to prove all these theorems from scratch using the epsilon delta language of limit of sequence and limit of function. So this type of things will not be covered in the Math 1013. And this type of thing is like more proof-based, and there's no calculation inside. Okay? And for the differentiation part, we will also learn rigorous proof to important results, such as Chern rule, which you will be taken for granted for the normal calculus course. But in the honor calculus course, you will prove Chern rule from scratch using epsilon delta language. You will also prove the Lagrange mean value theorem and the Cauchy's mean value theorem and the Taylor's theorem, also from scratch. Okay. Yeah. So right. So let me elaborate these key differences more by examples. Okay. So the first key difference you may encounter in the honor calculus course would be the definition of limits. So in the left part of this slide, this is what you will learn in normal calculus course. So let's say what does it mean by a sequence having a limit L in the normal calculus course? So you will not be given a precise definition or rigorous definition. So rather, you will learn an intuitive definition like this. So a sequence has a limit L if you can make the general term AM as close to the limit L as you like by taking the number n sufficiently large. So that's what you learn in the normal calculus class. But this definition is not rigorous and it's not precise. For example, what does it mean by as close to L as? And what does it mean by taking n sufficiently large? So how large should we take for n? And how close should we take for an to L, right? So in a normal calculus class, the definition is quite vague, and actually we don't care about this definition in the normal calculus class. Instead, we only need to know a surface limit law and a surface arithmetic law, and then we'll go straight forward to calculations type questions, right? Okay, and on the other hand, for the same definition in the, that is taught in the honor calculus course, you will be given a precise definition for limit of sequence in terms of the epsilon delta language. So the sequence AN converts to has a limit L, means that for every epsilon that exists a positive integer m, such that whenever n greater than n, you have the difference between AN and L is more than epsilon, right? So you have this logical statement for the definition of limit, right? So in the honor calculus course, what you need to know is you need to understand the logic behind this definition. And for example, the number epsilon here is used to quantify what does it mean by as close as. Okay, and the number n, capital N, is used to quantify what does it mean by taking n sufficiently large. So the definition here is more precise and more rigorous. Okay, and there are also implicit implications behind the definition, right? So what does it mean by for every n that exists? So behind this statement, it means that the capital N you choose should depend on the parameter epsilon. Okay, so that's the implication behind this sentence. So in taking the honor calculus course, you need to know the logic behind, and you need to fully understand the definition. Right. So same goes for the definition of limit of function. So in the normal calculus course, we will say that the function f has a limit at s equal. So the function f has a limit of L as x goes to a. That means if we can make the values of the function f arbitrarily close to L by restricting x to be sufficiently close to a. But what does it mean by arbitrarily close to L, and what does it mean by sufficiently close to A? So how close is this, right? So in the normal calculus course, you don't need to worry about this. But in the honor calculus course, actually you need to quantify this by adapting the epsilon delta language for the definition of limit of function, right? So here, the parameter epsilon is used to quantify, right, how the function f is arbitrarily close to L, and the number L and the number delta is used to quantify how x is sufficiently close to A, right? And behind this sentence, there is an implicit implication that the parameter delta should depend on epsilon. That means for each epsilon, you should have a different delta in here, right? So yeah, so this is kind of the stuff you will see in honor calculus, right? And let me elaborate more on this by examples. So let's consider this limit. Limit n goes to infinity of this quotient, this quotient of sequence, 3n plus 7 divided by 3n minus 5, right? So in the normal calculus course, you'll be required to calculate this limit or evaluate this limit by arithmetic rules and limit rules, right? So how will you evaluate this limit? So so it is straightforward, right? We divide on both sides by n, right? And then you see that as n goes to infinity, the limit law tells you that 7 over n and 5 over n goes to 0. And this limit goes to 3 over 3, which is 1. Right? So this is like straightforward calculation you will encounter in the normal calculus course, and you may have encountered this in M2 as well if you are taking HKDSE M2, right? But so this is easy peasy, right? Okay. So on the other hand, for the honor calculus course, you are not asked to evaluate this. Instead, you will be asked to prove that the limit equals to 1 using the definition of limit. Right? Okay. So what does it mean by using the definition of limit? Okay. That means you want to plug an to be like this general term, and you want to verify that this definition holds for the limit. Right? So what does it mean? It means that for every epsilon greater than 0, you want to find a capital N such that when n greater than capital N, the difference between the general term and 1 is less than epsilon. So that's what you want to do in the honor calculus course. And this is not very straightforward. There's not a straightforward way or general techniques of doing that. You need to make some estimation by your own and find out how the capital N should depend on epsilon. So this requires some trial and error and requires some insight into the question, but not straightforward calculation, right? So in this problem, after some work, you find that if you take capital N to be this number, then the difference between the general term and 1 can be estimated from above by 6 over n. And using this capital N, this thing is less than epsilon. Right? And in doing so, you have verified that for every epsilon that exists a capital N, which is explicitly given as the maximum of 5 and 6 over epsilon, such that when n is greater than a capital N, the difference between the general term and 1 is less than epsilon. And after establishing this, you have verified the definition of limits using the epsilon delta language. And this means that the limit of this sequence is 1. Okay, so this is kind of thing you need to do in the honor calculus course. And let me tell you that this kind of thing is actually the easy part in the honor calculus course. Okay, so this is another example, and my apology, I have a typo here. This should be square root of 2. So in the normal calculus course, you will be asked to compute the limit of this function, right? And this is, again, very easy. Even my grandma can do that. You just put in x equals to 1 and see, the denominator is not 0. There's no problem of plugging it in. And the limit is square root 2. Okay, so for the honor calculus course, you are asked to prove using the definition of limit that the limit of this function as x goes to 1 is square root 2. Right. So how should we do that? Again, we need to verify the definition of limit using the epsilon delta language. Right. So again, you need to do some estimation. You need to manipulate inequalities in a not straightforward way. Okay. And after some work, you have found that given an epsilon greater than 0, we choose delta to be the minimum between these two numbers. And with this delta, whenever the difference between x and 1 is more than delta, you have the difference between the function and square root 2 is blah, 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 smaller than square root 2 delta square. And by the choice of delta, this is more than epsilon. And so you have verified the limit. You have verified using the definition of limit that the limit of this function x equals to 1 is square root 2. Right? And you can see that the estimation you have done here is not very straightforward. Right. So this is like a key difference, one of the key difference between honor calculus and normal calculus. And you encountered this, I think, maybe in the first 3 weeks of the course. Okay, so another good example to illustrate the key difference between the normal calculus and the honor calculus is the natural constant E. Okay, so in Math 1013 or in high school, if you have taken M2 or like GC A level or AP or IB, you are mostly likely to be told that the natural number E, the natural constant E, is defined as to be this limit or this series or this number. Or if you are engineering school student, then E might be 3, and which also equals to pi. Okay, but yeah. Okay, but in the honor calculus course, we ask more. Firstly, why can we define E in this way? So why does this limit exist, right? So in normal calculus course, they won't tell you why this limit exists. You don't care about this. You just use this as a definition of E, and then you have some limit rule involving E, that is like E to the h minus 1 over h converts to 1 as h goes to 0. Right? Then using this limit law, you can do calculation regarding limits. Right? But you are not considering why E can be defined in this way. In the honor calculus course, you need to know why this limit exists from scratch. And also, you need to know why does these two expressions give you the same value, right? So, yeah, why we have this equality? And the way to show that is not straightforward. So it is not simply like left-hand side equals to right-hand side by expanding the parentheses. Okay, so but it requires more advanced estimation and techniques. And if you look at the value of E, it is like 2.7182A, etc. So it looks like an irrational number. But is it really an irrational number? Right? You can't know by looking at the values. So in the honor calculus course, you will be also concerning about this issue. You can use the techniques taught in honor calculus course to prove that the natural number E is an irrational number. Okay. Yeah. So let me illustrate more. So the first question is, why does limit exist? Okay. So because there is no, you don't know what is the limit. So in this case, you're not able to use the epsilon delta definition directly to prove that the limit equals to some number, because you don't know that number. You don't know about what number is. Instead, you will use estimate and the monotone convergence theorem to prove that this limit exists. So the monotone convergence theorem is a theorem you will learn in the honor calculus course, and it tells you some criterion of convergence of sequence. So to apply the monotone convergence theorem, you will need to satisfy two requirements. The first is that the sequence had to be monotone. Let's say monotone increasing. The second requirement is that the sequence should be bounded from above. And okay, and now to apply, so now we want to apply the monotone convergence theorem to show that this limit exists at the first place. So how do we do that? Okay, so you will need to do some algebraic manipulation. So using binomial theorem, you can expand the parentheses for each n, and after some algebraic manipulation, you can find that this general term equals to something like this. Okay, and from this general term and some careful observation, you observe that, oh, this is actually an increasing sequence. And from this general term, you can also see that there is upper bound for the general term by 3. Okay, so after establishing this, you show that the general term is an increasing sequence, and there is an upper bound by 3. So that you can apply the monotone convergence theorem on this sequence. And the monotone convergence theorem tells you that the limit of this sequence does exist. And so we define the limit to be the natural number E. So that's how we do that in an honor calculus course. Okay. And next question is E an irrational number, right? So in the honor calculus course, you can prove that by using techniques from elementary analysis. So maybe let me outline how to prove that and give you a taste of what you might encounter in the middle of the semester. Okay. So in the honor calculus course, you may expect that the midterm exam questions will be something like that. Okay. So firstly, we will use the series definition for E. So the natural number is the convergence of this infinite series, and then to prove that E is an irrational number, there's not a straightforward way. Instead, we will use the proof by contradiction. So to do that, we first assume that E is a rational number. That means E can be written as P over Q for some positive integer P and Q. And then we try to derive a contradiction using the definition of E. Right. So how do we do that? So after some observation, you find that by observing the partial sum as the K partial sum and the remainder, on one hand, the remainder of this series can be made arbitrarily small for large K because the series is convergent. So that's what you will learn in the course. And on the other hand, by the assumption, if E is an integer, then K factorial times E is also an integer. The K factorial times the K partial sum will also be an integer when K is sufficiently large. Let's say when K is larger than capital Q, than the number Q. So that means that K factorial times the remainder will be an integer when K is sufficiently large. Okay, and the idea is that these two observations should draw a contradiction. So on one hand, the remainder should be very, very small. On the other hand, this term must be an integer. Being an integer means that it cannot be very small. Say it cannot be 1/2, right? Okay, and after having the idea, you need to execute the idea by doing estimation, right? So how do you do that? Okay, so you estimate the remainder, that is this series, and you manipulate this using algebraic inequality. And you estimate this from above. Let's say after some estimation, you'll get that the remainder is less than 1 over K factorial times K. So that implies that K factorial times the remainder is less than 1 over K, which is less than 1. Right? But by this assumption, K factorial times RK must be an integer when K is very, very large. So this gives you a contradiction, because by the estimation, K factorial times the remainder is less than 1. Okay. So this is like the proof of why the natural constant E is an irrational number. And you can see that the proof is actually not straightforward. It is divided into several steps, and you need to make some key observations to think about how to go with the proof. Right? So you have 3 steps. The first step is proof by contradiction. The second step is to truncate the series into partial sums and remainder. And then you need to estimate the size of remainder. And lastly, you need to know that you need to show that you need to observe that K factorial times the remainder must be an integer by the assumption. Okay. All right, so this is the kind of proof you expect to see, or you're expected to do in honor calculus. And actually, the midterm exams in honor calculus will be like this level. Okay. So in the last example, let me also show you the difference between the exams between the normal calculus and the honor calculus. So the left part is past exam for 1013, the normal calculus. So let's say in this question, you are asked to evaluate the limit of the function. So the function is given explicitly. The calculation may be a bit cumbersome, but but they are explicit, and they are straightforward calculations. And also you are given some piecewise define the function, and you are asked to show that the limit exists for this expression by showing that the left side limit and the right hand side limits are equal. So like in these questions, although you are asked to show that the limit exists or not exists, but you don't actually need to use the epsilon delta language. But all you need to use is to show that the left side limits and the right side limits are equal. So the normal calculus exam questions are more straightforward and more calculation oriented. Okay, and on the right part of this page, these are some problems from the honor calculus exam. So now you can see that the tastes are completely different, right? So you are given some conditions of the function, and you are asked to prove some property of this function in a question. So the functions are not explicitly given. So unlike the normal calculus exam, the functions here are explicitly given. In the honor calculus exam, the function you are considering are not explicitly given. Instead, you are given some conditions that these type of function satisfied, and you are asked to use these conditions to derive some conclusions. So the proof, okay, so the problems are purely logical. So you are asked to work on derivations, and you are asked to prove some kind of statement or conclusion. So for example, in this problem, you are given a function f satisfying all these requirements, right? And then in this part, you are asked to show that there exists a unique point such that the function satisfies some property. And you can see there's some logic behind this sentence, right? So there are actually two things you are required to show in this single sentence, right? So you need to show that there exists something that satisfies this property. And additionally, you are asked to prove that such thing is unique. That means there's no other things that share the same property, right? So these are the type of questions that you are supposed to do in honor calculus. Okay. Okay. Right. Yeah. So now let me talk about the recommended prerequisites for taking Math 1023, the honor calculus. So if you are admitted through HKDSE, then you are recommended to have taken M2 and have M2 level 5 or above for taking Math 1023. And it is better also to have some exposure to the Hong Kong A-level pure math materials. That means it is better to have done some problems in like the former Hong Kong A-level pure math questions. Okay, and having an M2 level 5 star doesn't mean that you're guaranteed to achieve a good grade in honor calculus. And instead, it only tells you that you might be prepared for taking Math 1023. And actually, in the Math 1023, you're expected to learn everything from scratch. Everything will be new. Okay. So there are examples. There are students who achieve level 5 double star in M2 and core math, but had C grade in Math 1023. Yeah. So be humble to the honor calculus course. Okay. And if you are admitted through Gaokao, then it is recommended to have math score at least 120 to take 1023. And it is also better to have some exposure to elementary calculus and how to use differentiation to prove inequality. For example, how to prove this inequality for using differentiation. And if you are admitted through IB, GC, A level, or AP, it will be quite hard to tell whether you are prepared for the honor calculus course based on the score of this exam. So even though you achieve the highest score, it doesn't mean that you are well prepared for Math 1023. So it depends on how you learn math in high school and how your teacher taught math to you. Okay, because whether you are prepared for the honor version of calculus may not be relevant on how high score you achieve in this exam. As these exams are standardized exams that are similar questions over a year, but the honor calculus is quite different. So it actually tests you. It is not testing you about memory, but it is testing you about understanding behind the concepts. Okay. Yeah. So finally, let me give you some tips of math, how to do well in Math 1023. So firstly, rather than just memorizing techniques or formula, as you might have done for high school exam, it is better to try to understand fully behind the logic behind the proof. So understand every step of the proof, understand how the assumptions in the theorem was used in the proof. And you can test your understanding by writing out the proof for the theorem examples you have learned in lectures on your own. So that means after you think you understand the material, close the book, don't look at the solution. Try to work out the proof by your own, on your own, for those theorems and examples. And also ensure that you understand the assumption in the theorem and how these assumptions are applied in the proof, rather than simply memorizing the steps. Okay, so that means you should, like, by writing out the proof on your own, you need to create the proof by yourself from the beginning. You shouldn't memorize the step and like copying the step down. And finally, you can improve your mathematical maturity or improve your sense of math by thinking about counter examples of theorems and examples. Okay, so an example is like this. So normally, you encounter theorems in the honor calculus course, and those theorems comes with assumptions and conclusions, right? So, okay. So to think about counter examples, you can think about why those assumptions are necessary, and you can think about if one of the assumptions is removed, then where the proof of the theorem breaks down. So for example, composition of limits. Okay, so if you have two functions f and g, such that the limit of f as x goes to a equals to b, and the limit of the function g as y goes to b equals to c, then is it true that the composition of the limit is c? Right. So in Math 1013 or in M2, this is taken for granted. So that's the arithmetic rule that you will apply in doing all the questions. So you won't think about why this is true, right? And the function given in those exams are actually nice enough so that everything works nicely. But actually, in this theorem, there is an extra assumption behind why this works. You need to assume that the function g is continuous at y equals to b for this composition to work. Okay. And now the question you can ask yourself is this theorem still valid if you remove this assumption? And if not, can you construct a counterexample to it? And where the proof of the original theorem breaks down, if you remove this assumption. Okay. Yeah. And this is a counterexample that I give you. So you can take f to be this function and g to be, you can take f to be identically 0 and g to be a piecewise defined function such that g equals to 1 when y equals to 0 and g equals to 0 when y is not 0. So g is not continuous at the point 0. And you can see that the composition g composed with f is always 1. So but the limit of g as y goes to 0 is 0. So this conclusion fails for this counterexample. And why it failed? Because in this example, the function g is not continuous at the point 0. Yeah. So in learning the honor calculus class, you will see many these kind of theorems or propositions or questions, and you can think about why. You can think about counterexamples and why the assumptions are necessary to improve your mathematical maturity. Okay. Yeah, so I think these are all I want to talk about for the honor calculus course, and now it's the Q&A sessions. So you can ask me questions if you have any question.
Hasn't taken any math competition or got any prizes. Do you think has a chance to get admitted to the Chern class?
Yeah, I think so. So, yeah, so there are examples that students haven't taken any competition but still admitted to Chern class. So basically, you can think that the university level math is a whole new start. Okay, so it is like your second chance. So you can pay hard work and do well in the honor calculus course, and that will give you a chance to be admitted in Chern class.
Do you recommend the honor calculus for students who want to declare physics as their first major?
Yeah, so I think if you want to do theoretical physics in the future, then it will be recommended to take the honor calculus. And actually, the honor calculus is the required course for IRE physics. Yeah, so that means if you really want to do research in physics, then it will be recommended to also take the honor calculus for solid foundations.
How much time do students usually spend studying outside the class?
Yeah, so I would say there is not like a fixed time requirement, but normally I think if this is the first exposure of you, then maybe I don't know, maybe take as much as time as possible until you think you fully understand the concepts. You can try to do some problems in the textbook, right? You can try to do the problems and test your understanding. So I would say you should expect some time commitment to achieve good grade in the honor calculus course.
You still have time to drop it. So how many of you find it enjoyable, this lecture? Yeah, some do. Yeah. It's challenging, but as Aaron just mentioned, that you really need to spend some time. I remember students may spend almost 10 hours maybe per week to study the Math 1023. So if you already enrolled in many credits, then be prepared. If other courses are easy, then you can focus on calculus. But as Aaron mentioned, if you are IRE, you have to. And if you want to join the Chern class, you need to But to be honest, from my experience, not many students fail these two courses because I guess, well, I mean, students taking this course, they are very good, so not many fail this course. But students will be disappointed if they get C grade. So be prepared. It's difficult to get A, I think, right?
Yeah, maybe.
But C, I think I did see some students who got, for example, 5-star in DSE, the local examination, and he got B or C range in this course. So if you want to drop it, you still have time. But I think it's quite terrifying. But you can taste it in the first class because you took it 10 years ago, right?
Yeah,
So maybe it's different. But the same professor, I think.
not the same.
Really?
No, it's
Professor Min Yan.
oh, the same. Yeah.
Same professor. So you can taste it and then think about it during the actual period.
Yeah.
Any other question? Oh, one tips. You can also, if you want to find some problems to work on, then you can try the entrance exam for Tokyo U in mathematics. You can find it, Google it, and then you can find some problems there. Any other questions?
Yeah, I think the first homework will be usually assigned in the first day of the class, maybe in the first week of the class. Then you can try to work on the first assignment set and see whether you find it comfortable. Yeah, and then decide whether you want to stay with the class or not.
But it's very rewarding, right? If you want to pursue a PG degree in mathematics.
Yeah, I would say it will be a must if you want to pursue a PhD in math.
If I choose math honor instead of physics honor, can I apply for physics IR? Just like I'm only choose for math honor, and I did not choose physics honor classes. Can I apply for physics IR instead of math honor?
I think physics IRE, the honor campus
Yeah,
is
required.
but it's not a must.
Really?
Policy change.
I think 31314 is.
1-3, you have to take honor physics,
Yeah.
but the honor calculus is not a must. Yeah. But as Aaron said, if you want to do theoretical physics, then perhaps it's a good training. I study physics myself, and I complete my master degree here at MQ. So I would say math courses are very important tools for studying physics. I mean, if you want to pursue PG in physics.
Do you have any advice for Chem and Bob track students on math studies?
I won't recommend students. For Chem and life science tracks.
Oh. Yeah, so I think that will not be a plus. That will not be a must for if you study chemistry or biology. Yeah. So
Well, you can go to the honor class and, as Aaron mentioned, try to do the first homework and things.
yeah, you can try. Of course, you can try to challenge yourself by taking the honor calculus course. But if you don't take the course, this will not harm your career in chemistry and biology.
And then you can also audit if you just want to learn the material and don't want to ruin your grades or CGA, then you can audit the class.
I want to take data science, and I already talked to my mentor yesterday about which courses to take. Honestly, at first I'm not interested in honors, but because he said that I might be able to get better CGA with honors calculus, I said, okay, why not? I'm a guy who likes challenging things, but if I want to take data science with probability in minor for mathematics, how important do you think honors calculus is?
Yeah, so I think it would be I mean, if you want to like pursue further study in probability, it is also important for taking the honor calculus because if there is also an honor probability course offered by the math department, and actually in the honor probability course you will need to use measure theory to define what is called a probability space and something like that, and it also builds upon mathematical analysis. Yeah, so if you want to do that direction, for example, further, if you want to know what does it mean by like stochastic calculus and Brownian motion, those kind of things that's used in financial math, it is also helpful to take this honor calculus course and understand the epsilon delta language for your preparation.
So it should still help in understanding.
Yeah, it helps. Yeah.
Just for your information, if you really got a bad grade in the Math 1023, don't worry, because the formula for getting into data science, the formula must include the grade of Math 1014 or 1024, not necessarily 1023 or 113. So if you find it too difficult or you got bad grade, then you can shift to 1014 and then get a A or A plus, then you still have a very good chance to get to the data science. Why not challenging yourself? Yeah.
Okay. What score should we get to achieve A plus at this course?
So if only for this course there is no scholarship, right? But this course gives you a chance to be eligible to be admitted as a Chern class student. Then being a Chern class student, you can get scholarship. Yeah. So this course is like a cornerstone or step towards a scholarship.
We do have academic scholarship for students who's at the top, like the 10 percentile of the whole cohort. Yeah, but I know some of you already got an entry scholarship, so there's a maximum, there's a cap for the scholarship you can get at UST. So you can consult us individually if you're concerned about the scholarship.
Were the exams far more difficult than the kind of the examples given in the textbooks or the kind of examples provided by the professor in the lecture?
Yeah, so it depends on the professor. So normally the exam will be open book. So that means you can bring along your lecture notes into the exam room, and you don't need to memorize all the formula. But you need to ask your professor for that. So in my year, the exams are open book. Yeah.
Open book exam.
Yeah, open.
Really hard.
Yeah.
I want to know whether the problems in the exam is more harder than the problems in the textbook or the problems in the assignment.
Yeah. So I think this year the course will be taught by Professor Min Yan. So he will use his own lecture notes, and there are numerous exercises in his lecture notes, and I think the difficulty for his exam is a bit harder than his exercise.
For all courses,
For all courses, right?
So,
even the 101 students.
so how could I just practice in daily in my assignment, or I want to say that how could I do to prepare for the exam that is a bit more harder than normal?
Yeah. So as I said in this talk, there is not a general way to achieve good grade in Math 1023. So so this is unlike the exams in high schools that you can achieve good grades by past paper drilling, and in honor calculus course, the exams will be different from the past paper, and what you really need to do is to understand the concepts and logics behind. And sometimes in the exam, it requires some of your creativity. Yeah. So I would say try to practice the exercises in the textbook or the lecture notes not as much as possible, but with a considerable amount of practice and familiarize with how to use the techniques and how to apply the concepts in solving those questions, but not just memorizing the steps. Yeah, and that will give you a chance to achieve a good grade in Math 1023.
When you study this course, did you do exercise other than
I did a few. I don't know. I didn't remember.
Where did you find the exercises?
Okay, so yeah, so like from my own experience, so I also look at, so there are some good reference that you can refer to. One of the reference is Principle of Mathematical Analysis by Walter Woodin, and it is also called Baby Woodin by people. So there are some exercise in the book which you can do, and I did some exercises. So I think the difference between honor calculus and other and normal calculus is that, like in high school exams, you can do like repetitive exercise to build up like muscle memories, but in Math 1023, this approach doesn't work. There's nothing like muscle memory to be developed by past paper drilling. So instead, what you need to develop is this thing called mathematical maturity. It's the way of how you think. It's the way of how you apply logics and how to use these assumptions. Yeah. So that means it doesn't mean that the more exercise you do, the better grade you will achieve. So that means you don't need to do many repetitive exercise. So what you can do is you can do some exercises. You can do some like classic problems and think about some counterexamples. As long as you think that you understand the material, then I think that will be okay. So at least from my own experience, that's the approach I adopted. Yeah, that's the one. Yeah, you can find this book in library, and I think you can also download this book online. Yeah. So I would say the level in this book is a bit harder than the honor calculus because it is basically mathematical analysis, but they share the same spirit and similar context. Let me see. Yeah, I think maybe another book is analysis by Terence Chow. So one book will be like problem books in mathematics. In real analysis. So, yeah, this book is also a good reference that you can take on. Then you can find this book in the library, or you can actually download it in the web. Yeah, there should be a PDF version. That means you can log into the library with your HKUST account, and then you should be able to find a link for download. So you can like find this book in the library browser. So I won't recommend you to skip classes unless you know, unless you can fully understand everything. So unless you know how to do all the assignment problems easily. Right? If not, then you should stay in the class.
Concerning the time, I guess we can end here. If you still have questions, you can come down and then ask Aaron directly. Okay? Is it okay? Okay. Thank you. We will share the PowerPoint.